Hello, and welcome to the BMC Quick Course Series. I'm Andy Andrews, and I'm a software consultant for the BMC mainframe batch products. In this demo, I'll provide an overview of MainView Batch Optimizer, also known as MVBO. MainView Batch Optimizer reduces elapsed time for batch processing by removing embedded wait times. It reduces I/O wait time using enhanced I/O routines. MainView Batch Optimizer runs jobs and job steps in parallel so the jobs do not waste time serializing. Also, it exploits parallel sysplex utilization. MainView Batch Optimizer includes the Data Optimizer component, the Job Optimizer component, and the Job Optimizer Pipes component. Let's discuss each of these components in more detail. The Data Optimizer component works with both VSAM and QSAM files. It's transparent to existing JCL and applications. The Data Optimizer dynamically selects optimal buffer values and processing techniques based on current system resource utilization. For example, it considers paging rate, CPU rate, below-the-line storage, and more when determining just how to optimize batch processing. Specifically, for QSAM files, also known as flat files, the Data Optimizer adjusts the region size to improve storage management. It takes advantage of extended addressability to acquire resources without having an impact on existing batch jobs. All of the optimization is transparent to the application, so you don't need to make any JCL or program changes. The Data Optimizer exploits VSAM options like deferred write and VSAM load mode processing to run processes more quickly and efficiently. The Data Optimizer chooses buffer values based on the access intent of the program. For example, if you open a file with random intent, the Data Optimizer establishes an LSR buffer pool and dynamically switches to LSR processing. For sequential programs, the Data Optimizer uses NSR buffer techniques. If the program includes both random and sequential processing, the Data Optimizer initially starts with LSR processing for random intent. It then captures history data and will dynamically switch between LSR and NSR processing as needed. For QSAM and BSAM datasets, these are sequential files, the Data Optimizer builds special buffers above the line that allow pre-reading of large amounts of data. This significantly reduces the wait time for the data to be returned to the programs. The Data Optimizer replaces the low-level I/O processing, providing complete control of buffer management and physical I/O requests. All I/O requests are satisfied by the product's internal buffer manager. For sequential processing, MVBO reads large amounts of data and uses overlapping I/O techniques to maximize performance regardless of blocking characteristics. All of this processing is transparent to the application and no JCL or program changes are required. MainView Batch Optimizer policies are sets of rules that you set to control how the product works in your environment. By setting policies, you get optimization that is transparent to existing programs. Sample policies are provided, and you can make changes through the ISPF interface. You can use DD overrides for testing and ad hoc changes. You can also use a user control exit for complex algorithm selections. Let's look at a report that shows the difference that Data Optimizer made in one situation. A VSAM file had about 3.5 million reads and about 3.5 million points. This is in one execution. And we can see that this program skipped sequential processing. Without the Data Optimizer, VSAM would have needed over 10 million physical accesses to the index and data blocks. However, with the Data Optimizer, this was actually reduced to 2 physical index reads and 9 physical data reads. We have seen what the Data Optimizer can do, so now let's take a look at the Job Optimizer. The Job Optimizer exploits parallel execution of jobs with step splitting. In other words, it runs multiple steps, those without data dependencies, that are in a single job. It will run them in parallel versus serial mode. Step-to-step piping enables parallel steps to execute when step 1 writes and step 2 reads the same file. A data pipe is a buffer in memory that data is written to. Because the reading program reads directly from the pipe, no I/O is required. When the writing program finishes, the reader program also finishes. Job Optimizer splits job steps for piping and concurrent execution based on history and policy definitions that you define. Let's take a look at a batch job with and without job optimization. On the left, you see a 6-step job where each step runs serially. Step 1 writes a temporary file to DASD. Step 2 reads that file. Each step must then wait for the preceding step to end before the next one begins. On the right side, you can see the same step with job optimization. A user-defined policy enables steps 1 and 2 to run at the same time. Step 1 runs on a JES initiator, and Step 2 runs on a spawned initiator called an XJS initiator. Before we go into piping, we need to understand an important concept. We'll call this the pipe rule. The pipe rule says that you can split going out of an update step, but you can't split going into an update step. Step 3 shows the pipe rule in effect. It serializes the work, as it also does with Step 4, even though the work is being done on a different LPAR. The Job Optimizer established a pipe from Steps 5 and Step 6 on a third LPAR. Step 5 reads the output from Step 4 and pipes it directly into Step 6. Parallel processing can significantly reduce the elapsed time for batch processing. Here's another way to see the benefits of job optimization. Parallel processing takes less time than serial processing, and eliminating I/O saves valuable CPU resources. MainView Batch Optimizer takes the idea of parallel processing to another level with job-to-job pipes. Let's take a look. MainView Batch Optimizer can establish pipes between a reader and writer within a single job or externally to another job. Step-to-step piping happens when a single job is submitted by the scheduler. However, job-to-job piping requires that you make changes to the scheduler so that 2 jobs can run as co-requisite jobs. With job-to-job piping, 2 jobs would be running on the initiators at the same time. It could be that Step 5 in one job needs data from Step 8 in another job. When the 2 jobs reach the steps that include the pipes, they are held until they are synced up. MainView Batch Optimizer then establishes the pipe and starts piping the data. MainView Batch Optimizer communicates directly with BMC's Control-M product to understand the nature of jobs and will ensure that all co-requisite jobs of the collection are scheduled at the same time. Let's look at this example. Without piping, you can see an extract program, something common in month-end processing, that sweeps through a database and writes a flat file. The file goes through downstream processes and creates report 1, then report 2, and finally report 3. With pipes, the extract job writes to all 3 downstream processes simultaneously. When the extract job is finished, the reports are also finished, saving significant elapsed time. MainView Batch Optimizer provides comprehensive, intelligent, dynamic batch, data, and job optimization. It enables job steps and jobs to execute in parallel, dramatically reducing the elapsed time for batch processing. It also balances batch jobs across a parallel sysplex. Thank you for your time. For more information about MainView Batch Optimizer, see the related demos on the right side of the web page. For more information about any BMC mainframe product, see the URL shown here.